All right. Can you hear me, everyone? Is everything okay? So yes, it's such a pleasure to be here. I really appreciate to have all of you here with me. We are all tired, last talk of the day. I am pretty much the only thing separating you from some beers, so yes, stay with me. Today we are going to talk about GitHub Actions, right? My goal here is to provide an overview of GitHub Actions as a platform. So more or less, 20 minutes crashing course, so everyone can get used with some terminology. And after that, dig a bit into some topics that might be useful for you if you use already GitHub Actions or if you pretend to adopt GitHub Actions for your project. Just out of curiosity, how many of you actually use GitHub Actions in your projects, or maybe are interested? Okay, not that many, so this is good, I guess. So let's start. First of all, crashing course, right? So let's jump into it without further delay. I like to share with everyone that if you want to understand the GitHub Actions as a platform, you need to master these 5 concepts. Only 5 of them. You need to know what a workflow is, what a job is, what a step is, what a runner machine is, and what a trigger event is, right? So 5 concepts. And in order to learn about them, let's start from the most abstract one until the most low-level one. So the most abstract concept that we have in GitHub Actions is the concept of a workflow, right? What is a workflow? A workflow in GitHub Actions is a pipeline orchestrator, right? Or a job orchestrator, if you prefer. But not only that. In GitHub Actions, the workflow is pretty much the instance that will intercept trigger events, the events that pretty much kicks your pipeline in. For instance, some push that, let's say, some branch just have received, or a pull request that eventually was opened, or a tag that was created. So these are pretty much the classic ones, but we have other ones that are pretty much tied to the GitHub as a platform. Pretty much like, okay, a GitHub release was created, or maybe someone triggered a workflow programmatically using a REST API call. Someone posted a comment on GitHub, these kind of things, right? So yes, workflows are pretty much it. So it's pretty much like an umbrella that orchestrates jobs and also are in charge to receive the trigger events that kicks pipelines. So when we talk about that, we can see here an example, right? So we have one workflow that defines one pipeline or one job called build. And that particular job will be triggered when the pull request event arrives to the runtime. So quite simple. But that could be different. We could have something like that. A workflow called an internal library with 2 jobs. The first one is the build with n steps that make sense to that workflow. And the second one is the publish. So I will publish that library when a given tag is created, right? So here we have something different because publish won't be triggered by the trigger event. Right? It's different. It will be triggered, but it will be orchestrated by the workflow, right? OK, so we managed to learn 2 out of 5 concepts already, workflow and trigger events. So let's talk a bit more about jobs. But before that, workflows in GitHub Actions are defined by configuration files, defined by YAML language, Such files, they live in this conventional folder, so inside the .github/workflows for your project, and we can have as many of them as we want. So this is nice because eventually we want to split that configuration, makes things a bit more maintainable and so on. But yes, we know that as software engineers, we don't like YAML that much, do you know? I mean, we use Kotlin every day, type safe, super nice IDE support, these kind of things. But the good news here is that IntelliJ does a really great job in terms of supporting the YAML dialect that GitHub Actions speaks, right? So you get some hints inside the IDE. I mean, it's a nice support, right? So it's pretty much like as first class as we would have with VS Code, for instance. All right, so workflows, okay. Trigger events, okay. So let's talk about runner machines and jobs. These two concepts are quite tied with each other, and they are quite simple as well. Essentially, a runner machine is pretty much the build machine, or the worker machine, right? Every single time that we deal with CI and CD, we have this concept around, right? Some virtual piece of hardware that will run the workload, right? And we have some operating system there, and that's it. In GitHub Actions, every single job is attached to a runner machine. There is no such thing like a job without a runner, right? And the job itself, it matches exactly the idea that we have of a pipeline, which means a sequence of steps, right? Atomic tasks that run one after each other. So that's it. So a job is a collection of steps that run sequentially. And each job is attached to a runner machine. In GitHub Actions, we can have several types of steps. I won't go for all of them because I don't have time, but just to mention, a step can be a regular shell script command that I run, right? A step can be a composite action, which is pretty much a shell script encapsulated as a GitHub action. A step can be a nested composite action, which is an advanced feature, and a step can be something defined by your own code, using your own program language. Particularly, GitHub Actions has support to two major models of creating reusable pieces of pipeline as code. Either you create your custom GitHub action with JavaScript, or something that compiles to JavaScript, for instance, TypeScript, or you encapsulate your particular pipeline logic, let's say with Python, or I don't know, something like that, Ruby, you choose that, and you package it as a Docker container, right? Why is this important? Because according to the runner machine that we have in place, not all types of actions are supported. Particularly, the Docker container actions, they are not enabled by default when you opt in for runners provided by GitHub. We will get more into runners in just a minute, but keep that in mind. If you want to have, let's say, the max compatibility when running any piece of actions that you find in the wild or you define by yourself, just go with Linux runners, right? Because they are the most flexible ones. All right, so that's it. So we managed to actually cover almost all the concepts. Yes, maybe we can see an example, right? I am not affiliated with the Signal Messenger, but this project is pretty much developed in the open source. And yes, because GitHub Actions is free for open source, I'm not affiliated with GitHub as well, they use GitHub Actions to run some builds there. And particularly, we can see here that, okay, they have that particular actions tab, which means that GitHub Actions is enabled for this particular repository. We can see that they have 3 different workflows, and I am particularly interested in this Android CI workflow. And when we go to the execution detail, we can see the latest workflow runs for that particular Android CI workflow. If we go to the YAML file defined by that particular workflow, this is everything that we have there. We don't have that many lines, right? So let's see how those 5 concepts match against this workflow definition. First thing that we have, okay, we have a name, right? So a workflow must have a name because this name pretty much appears in GitHub Actions UI here and there, so easy. After that, we have the trigger events, right? Oh, I think things are kind of, super, not quite visible there, but yes. Okay, so we have here trigger events. So in this case, we can see that this particular workflow kicks with two events, either when a pull request is created or when a push actually arrives in the master branch or some of those release branches, I guess. Okay, easy. This workflow defines only one job, and this job will run in a Linux machine. This Linux machine is provided by GitHub as part of the open source offering. Sounds good. Our job is a collection of steps, and when we go to the detail of such steps, we can see that, hey, first thing they will do, they will pretty much check out the source code in the runner machine, and this checkout is actually done by one custom GitHub action provided by GitHub itself. Every single time that you see an action that uses this type of coordinates, kind of actions / something, that particular actions organization belongs to GitHub. This is a coordinate for an open source GitHub repository, as we will see in just 1 minute. But just keep in mind, every single time you see actions / something, this particular custom action is provided by GitHub. So okay, so this repository is pretty much fetching the source code in the first place. After that, it is pretty much configuring JDK 11 to run the build, which is fine. They run a bunch of things like the validation for the Gradle wrapper in order to make sure that the wrapper jar file is not tampered for some reason. They run this particular, I don't know, this particular command from SDK Manager. I don't know why. I didn't dig into the details to learn why they need this. And they run just one quite straightforward Gradle command to have a build. OK. After that, they use a conditional step, because we can have that, although I don't like that much to have if in YAML. It's pretty much like have if in XML with data binding. So, I mean, sometimes we don't have other options. So I think this is the case here. So if we have a failure in the workflow execution, actually in the job execution, sorry, then what will happen is that that particular upload artifact action provided by GitHub will collect test reports, assuming that there is derived by testing that actually failed, and will upload as part of the artifacts that can be attached to the workflow execution, right? So it's not a big deal, right? We have here a couple lines of YAML file. We have a workflow defined by multi-triggers that defines only one job. It has 5 mandatory steps and 1 conditional step. So yeah, that's it. We are almost there. When talking about that particular style of defining or using GitHub Actions, custom GitHub Actions, we need to keep this in mind, right? Every single time we see that uses keyword as part of the dialect, what we have there, what we supply there is a coordinate for an open source GitHub repository, right? In this case, actions/cache. And then we have at v1, which points to a GitHub reference, in this case, Git reference, sorry, in this case, a tag, a Git tag, right? But we could point, let's say, to the master branch if you want. Don't do that, but you can do. OK, so we have here. So this is pretty much the association between the coordinate and actually what we are importing as custom code as part of the pipeline. All right. Given that, it's always a good idea to go to that particular repository and check that action.yaml file. Why is that a good idea? Because that file is pretty much the file that GitHub Actions runtime reads when executing that action. And that file, sorry, is the manifest of the public API defined by that action, which means it defines the inputs accepted by that action and eventually outputs exposed by that action to downstream steps inside the same job, right? We eventually are not super interested in outputs, but for sure we want to know which kind of inputs we can provide. And this file is pretty much the source of truth that, I mean, documentation eventually is not up to date, but this file is always up to date. Last but not least, GitHub keeps pretty much App Store or Google Play for open source actions. You know, you can go there to the GitHub Marketplace, choose that particular actions submenu, and type any kind of term you want, and then you can find there, okay, which pieces of pipeline are already created, so I do not need to create that particular logic by myself. Easy. So that's it. So we can go for beers, I guess. No. Before going for beers, let's talk a bit about scaling pipelines, right? This is an interesting topic because we know that Android projects can be big, right? They can grow a lot and so on, and eventually the pipeline is an issue. Particularly, let's focus here in the runner machines provided by GitHub. Let's say you have an open source project, or let's say that you want to pay to GitHub to use the hardware, the virtual hardware, sorry, GitHub provides. All right. When we go to the specs of such virtual hardware, we know that, hey man, that virtual hardware is not super powerful. You know, I mean, probably my phone is kind of more powerful than some of those machines. Do you know? So yes, this is pretty much in the documentation and so on. So I don't know. We may have an issue when trying to push a big workload over these runner machines, right? Luckily for us, we have options. The first option is pretty much not use a runner provided by GitHub, but actually define our own runner. We can do that. We do that at N26. Yes, so this is an option. I won't discuss this option here. It's not trivial how to do that. It looks trivial. Eventually, it's not trivial, but that's definitely an option. Another option is pretty much do a bit more stuff in terms of how do we execute things, right? Because let's say that you have a single job, it's a big one, heavy tasks, and one after another, you know, eventually to have a fast feedback cycle on top of that execution, you need a big runner, big machine, right? Otherwise, it will take forever. But what you can do is eventually not focus in the, let's say, scaling that execution vertically, but try to scale that execution horizontally. That's possible with GitHub, and we will see how we can do that. We have two models to do that. The first one is something called build matrix. I love this feature. I mean, really, really love, because, I mean, it just cuts a lot of boilerplate that eventually we would have. To explain what is a build matrix and how we scale pipelines with it, I will use as an example the Detect project. We all love Detect here, right? So amazing project. And yes, because Detect builds on open source, it uses GitHub Actions as well. Particularly, I am interested in this particular pre-merge checks workflow they define. If we go to that particular workflow detail in the GitHub Actions UI, you can see they spawn a lot of jobs. But most important, it seems they spawn the same Gradle job with different configurations. You know, like, okay, the 3 major operating systems and some numbers, right? So they do that. If we dig a bit more and we check the implementation detail, we can see that, okay, what they are using here is something called build matrix. And they define the dimensions for that matrix, specifying 2 dimensions, one for the operating system, another one for the JDK. So in this way, they can run the checks for detect against all the measures combinations, right? So measure JDK releases, right? The LTL's releases, and also the operating systems. We can see that the values defined by those dimensions are pretty much fulfilled by that syntax there, where GitHub Actions will know that, hey, now for that matrix OS, I need to take one of those values, you know? And we can see that such syntax spreads for several parts of the configuration. We are not interested in that configuration. We just need to keep in mind here that, hey, we can define that in that way. So by doing that, we achieve something like this. We define a matrix with some dimensions, and GitHub Actions will pretty much spawn several jobs. And remember, each job runs on its own runner machine. So if I define, let's say, a matrix with dimensions 2×3, then I will have 6 runner machines running in parallel with all those different configurations, right? So I am scaling my pipeline horizontally. I don't need to repeat those configurations manually and pretty much run all the combinations inside the same runner. So that's a nice feature. But there is limitations, right? So pay attention that, this feature is limited by your GitHub plan, right? And also there is a max number of jobs that you can spawn per workflow. So it scales, it's okay, but it won't scale endlessly, you know, so it has a limit. Okay, after that, we can also scale our pipelines horizontally by taking advantage of something called custom topologies. This is not exclusive for GitHub Actions for sure, but particularly GitHub Actions has a very nice take for this thing here. And what is a custom topology? A custom topology means that instead of having one big pipeline with tons of steps, one after another there, I will pretty much split that pipeline into different pieces, or in the terms of GitHub Actions, different jobs. For sure, each job will be different, you know, because some jobs will be bigger because it will run, let's say, more heavy tasks, other jobs will be smaller, simpler. Okay, and most important, not all the jobs will be defined by the trigger event. Eventually, a job like job 4 will require that job 1 is complete and also job 2 is complete, so on and so forth, right? So this is pretty much an architecture or a topology, right? How can we do that with GitHub Actions? Before that, note that in that particular topology, job 1, 2, and 3, they run in parallel because each job runs on its own runner machine. At the same time, job 4, 6, and 5, they also run in parallel, potentially in parallel. So, okay, so I have more machines pretty much taking care of the workload. How can we do that with GitHub Actions? Luckily for us, it's quite simple. Needs is everything you need. So we have that particular keyword called needs, supported by the dialect GitHub Actions understands, and that's it. By doing something like that, you instruct GitHub Actions that the second job should start as soon as the first one finishes. So in this way, I can pretty much chain 2 jobs. If I can do that, for sure I can do something like this, which is called funning to a job, which means that, okay, I have the first job and the second job running in parallel, potentially in parallel, and after the 2 of them complete, then the third job will start. This is called funning to job, and we just need the array notation, classical array notation, to have something like that. If I can fun into a job, for sure I can fun out from a job, which means that after the first job finishes, second job and third job will start. Again, needs is everything you need. So it's that simple. By leveraging this particular feature, I can achieve a topology where I can have more machines doing the work. Even those machines are not that powerful and not that big. Let's go back to this the workflow we saw from the Signal Android Messenger, right? They define only one job that takes, I don't know, 20 minutes to run, because they run the QA build there, hence obfuscation, heavy tasks. Okay, that's fine. But I can have something like this. And now we can see the difference, right? So we can see that here I have several jobs running, and they have an orchestration. And this orchestration is driven by the workflow. And now it should be clear the role of the workflow in the model provided by GitHub Actions, right? Shameless plug, this is a project of mine. It's pretty much like a live laboratory where I experiment a lot of stuff, GitHub Actions included, right? All right, I don't know how much time do I have, but I still have some minutes, I guess. I want to share with you a study case, right? Something that I did. We had today some talks around screenshot testing, right? We have at least 2 talks talking about screenshot testing. And particularly, I came up with an example. And my example, it's also defined in that live laboratory, right? So you can just go there and pretty much look the code directly. My example here is, OK, I want to have screenshot tests for my application. But I want to have screenshot tests against different form factors. Is that possible? If you go directly to the third-party plugins that we have around, let's say Shot plugin or Facebook for Android testing plugin, it's not possible at plugin level, right? But eventually, I want to have that. So in that particular project, I use the Shot plugin provided by this nice guy from the open source community, right? It's just a Gradle plugin that facilitates a lot of things around screenshot testing, pretty much providing the 2 main tasks, record screenshots and verify screenshots. OK. The thing here is that why it's kind of tricky to have different form factors for screenshot tests. Because in this case, for a given screenshot test file, with some tests there, the plugin will generate 1 screenshot per test name. And that particular image file will have that particular file name according to the conventions. And the plugin expects to have those files inside the convention folder, screenshots/debug for your particular module, right? OK, so that particular convention location, I mean, the bug variant here, is where the plugin saves or records the screenshots. Hence, if I have this device, OK, I will have that particular set of files for this device. But if I have this particular device, the same names, the same file names will be generated, but the files themselves will be overwritten by the plugin, right? So, OK, so this is a limitation driven by the plugin. So first thing that we can do, we can hook into the third-party Gradle plugin and try to do something in order to work around this limitation, right? If we manage to do that, OK, we are really, really, really good. But eventually, we can do something different and eventually simpler as well. What if I told you that, OK, let's say that I have these 2 form factors and I capture or record screenshots for both of them. But I don't use the conventional folder in the source code, in the source version control to store those files. I store them somewhere else, but I have them beforehand. What I can do, at pipeline level, I can define my target device. I can copy those images inside the conventional folder. I can spawn the particular emulator device to match that particular screenshot, and I can invoke the Gradle task to run my tests. To do that, what I did, first of all, I defined this particular conventional location, right? So 2 devices here. I am an old Android engineer, so I mean, I am from the days where Nexus 4 was a thing, right? So a long time ago. And then, OK, I have these 2 devices. Amazing. After that, what I can do is pretty much decide that, OK, I have a topology here. But most important, define a build matrix where the conventional folders I use it, in this case, Nexus 4 and Pixel, will be kind of defined by the dimensions of that matrix. Only one dimension. OK. After that, I can run my steps. I can check out my code. I can run a particular shell script to synchronize those files inside the conventional folder, screenshot/debug. I can do this a little bit of Kung Fu here. I mean, this is a live laboratory, right? So this is how we run a GitHub Actions we define inside our own project. But this here, this particular custom action here is just a glorified map that converts that particular folder name, Nexus 4, to that particular Nexus capitalized space 4 name. And why I do that? Because then I input that particular string as the device profile that will be used by this open source action that I use to spawn the Android emulator, right? After that, as we can see, that particular action accepts a script as an input, which is pretty much the Gradle command I want to run. Why do we have this open source action? Pretty much because this action waits until the emulator is ready to run any kind of things, right? So it's kind of asynchronous. So that's it. By doing that, now we can pretty much figure out what the sync script does. It's really simple. Just copy the images recursively, and that's it. After that, we can see that, hey, part of my custom workflow relates to those screenshots, and I have tests for both form factors, right? And I didn't have to do anything with the plugin. I use exactly the same configuration, and that's it. And that script is also available for developers in the repository, in this case, only myself, so I can always sync those screenshots locally if I want. Sussex, amazing. All right, my last minutes, I guess, some Android tips. I will focus only in two tips, right, when using GitHub Actions for Android projects, because I am running out of time. The first one relates to the emulator I just talked about. Emulators are hard on CI, and GitHub Actions is no exception, right? Particularly, this guy here from the community provides these nice custom GitHub Actions that spawns an emulator and waits until the emulator it's kind of fully booted and ready to be used, right? Disables animations, do a lot of stuff for you, and then runs a particular script you want, let's say a Gradle task. OK, but there is one catch, and the catch is this action is kind of intended to be used on Mac OS runners. This is pretty much because a limitation related to the runners provided by GitHub. By default, only the macOS runner will be able to run an emulator at full speed, right? This is not possible right now with Windows runner. I don't think so. I mean, maybe I'm wrong, but for sure it's not possible with the Linux runner. Why is this an issue, especially if you pretend to pay to GitHub to use their runner machines? Because macOS machines provided by GitHub are expensive. So they cost kind of 10 times more than a regular Linux machine. So ensure that your credit card, it's kind of has a, I don't know, huge limit because the bill will come. So yes, eventually this is an issue. Another tip that I would like to talk briefly about is how we do caching at CI, especially Gradle caching, right? Why is this important? Because in GitHub Actions, and not only on GitHub Actions, but particularly on GitHub Actions, every single job will run in a virtual machine that boots in a clean state, super clean state, which means that you don't have any memory from the latest build you run from that particular project, whatever the Git branch or anything. It does not have memory. If you want to have that memory, then you need to kind of implement that memory by yourself. Not actually implement, you need to realize how do you do to have that memory, right? Which means that, probably we'll have some cloud storage in place where we save, let's say, the state of the build, and when the next workflow kicks in, or when the next job kicks in, I restore that particular build state, so I can make the most of the Gradle caching, right? Why is that hard? We have a couple of hard questions like, how do we define the entry keys? How do we compute the entry keys, right? Entry keys that will maximize cache hits. Here we are talking about caching terminology, right? What should we cache? Should we segregate the files per job if you have different jobs with different tasks, these kind of things, and much more questions. This is a hard question, and to answer such a hard question, we have some options available. For instance, we have a built-in cache capability inside the setup Java action provided by GitHub itself. It's nice because it's kind of zero conf. We just need to instruct the action that, I want cache, that's it. And the action will try to figure out the best approach for caching, which is quite nice for simple projects like simple libraries or so on. Eventually not that good for multi-module projects. We have the actions/cache provided by GitHub as well, but this one is probably the hardest to use because it's intended to be the most generic one. So eventually you use this same action for multi-module Gradle projects, but eventually also for Python projects or whatever projects, right? We have an action provided by Gradle itself that does a lot of things like, it's easy to configure because it has sensible defaults, it supports caching for tasks, for the distribution itself, it does segregation per job, a lot of other features, right? So I won't go in all the details here. This is just to illustrate that CI caching is not that trivial. It's not that, I'll just enable and everything will work kind of super nice out of the box. It's not like that. And yes, some final remarks, because we are all tired and aiming for beers, I guess. We have an open source model around all the custom GitHub actions that we have in the marketplace and so on, and this model is quite powerful, right? So this is nice. You can publish your own actions in the marketplace. I should do that, I guess. In GitHub Actions, it's easy to scale your pipeline horizontally. This is important, right? But your pipeline can also scale vertically if you provide, let's say, a self-hosted runner. For sure, it's an awesome option for open source projects you have because it's free, right? So free CI should be like, I get free food, I guess, or free beers. So, I mean, I will never complain about free beers. But you may face some unique challenges, especially if your Android project is quite big, multi-module, hundreds of modules, I don't know, dozens of developers, at least with the offering that GitHub has right now. I am this guy. I am from Brazil. I work at N26, not here in Berlin, but in Barcelona. I will publish the slides for this presentation on that particular Twitter handle, so feel free to check them out later. As I mentioned, I work at N26. Please check out this QR code so you can learn more how we do Android in our teams. And yes, I really appreciate you for having me, and thank you very much.